Alright, hello everybody. Welcome back. Today we're going to be talking about piecewise functions. So piecewise functions are a bit hard to wrap your head around when you first learn them, but they get pretty simple later on. So, yeah. So piecewise function is a way to define a graph in parts, kind of. So, for example, so far what we've been doing is we say that y equals f of x, right? All good. And then we just graph it and we get some graph, right? But, yeah, so let's say we did like that and we got that, right? Now, what if we wanted a graph that looked like this? And then on this side, it's a line. Technically, this is a graph, right? Because, like, you know, it's just a graph. It passes the vertical line test. It just seems like a graph, right? But I don't think we know the equation of it on the top of our heads. So actually, I'm gonna make this a bit easier to first learn. Let's say we had something like that. So we see that, let's like divide it, alright? So if we divide it over here, we said this part is a line, and this part is a parabola, kind of, right? And this middle point is a stopping point, right? Now there will not always be like a common stopping point. Sometimes it might be something like that, and then up here it continues, right? Like that. But notice that both of them have this point, so it fails a vertical line to that one point. So what we can do is either we can have a hole here and then a circle here, or vice versa, like that. What this means is that at this one x value, we have to choose one of them, and we just have to choose one of them. So yeah, if they are the same, it doesn't matter, right? Because they have the common point. So yeah, we notice that one part of it is like that, the other part's like that, and they don't always have to be at that line. They don't always have to be just two. You can have three. Let's say parabola here, and then up here we continue like that, and then yeah, let's do like that, and then down here we have, I don't know, maybe another line. Alright, yeah, we can just continue here, continue there, right? That's also a graph, but it's in parts, so we need to find out how to graph that. Well, it is in parts, right? So what we can do is we can just look at one part and then look at the other. We can look at one part and the other, right? We can just look at the parts like that because we know how to graph those. So what we do is we say y is equal to, then we put this weird curly bracket, and then at the top we put one condition, or like one thing. So let's say we have f of x. So actually let's say f1 of x, alright? Then f2 of x, dot dot, up to fn of x. So these are all different functions, alright? Now, we can't graph a bunch of functions and make it one function. So we put commas after them, and then we put conditions. So what do you mean by conditions? Well, you see, if you look at this middle graph over here, right, then we see that it's a line when the x value is less than 0, or yeah, less than or equal to, or less than, either way, because yeah. So we'll say less than. So so when x is less than 0, it's this graph, and when x is greater than 0, it's the other graph, right? So we just put conditions here. Now, I kind of have to do a few examples before we can understand it. So, yeah, let's do it. Let's see, this is our graph, right? Or this is our, coordinate grid. Then let's graph something. Alright. Say that. And then we can put a circle here, and then an open circle there. And then here we're gonna go like this. Now what does this mean, really? Well, again, actually, let me do something different. Yeah, let's go for this. Okay, so now we have y equals, then, alright. So now, what is this line? Let's say we did continue it like that, right? That's just y equals x, right? So we have y is equal to x, but it's not the whole graph. It's only when x is less than or equal to 0. Why is it less than or equal to? Why not less than? Well, because we have this open circle here, right? So yeah. Now we need to graph what happens when x is greater than 0. Then up here what we have is let's see what is that line? We know how to graph lines, right? And how to look at them, analyze them. So this y-intercept would be 1, 2, 3, 4, 5, and then the slope is rise over run 1 over 2. So it's 1/2 x plus 5 when x is greater than 0. Now, what if we let me redraw that. Alright, now what if we switched it up? What if we had an open circle here and a closed circle here? What would that mean? Well, what we would do then is we'd have a less than here and then a greater than or equal to here. We just move the equal one, the equal part, right? Alright, let's do another example. That's not a good graph. That's good enough. Okay, cool. So now, how would we graph this? Wait, nope. Actually, let's put a little closed circle there, and then down here we'll put open circle, and then we'll go this way. Alright, so now how do we graph this? I have another idea. What if we did like that? How do we do this? Well, we have y equals, oh, oops, what am I doing? It's gonna, I guess I'll do it. Okay. So now let's look at this, right? What is that? That is a slope of 2, right? So 2x. Now what's the y-intercept? It doesn't intersect the y-axis yet. But if we did continue it, it intersected up here. And that is 1, 2, 3, 4, 5, 6. So it's 2x plus 6. And that's when yeah, sorry. So now we can just erase that part. Alright, so now that's that part. Now that's when x is, as we can see, when it goes to negative infinity, it keeps continuing, but it stops at x is equal to -2. So it must be less than, and it's a closed circle, so it's less than or equal to -2. Now the next part is this. What's that? well, it's not a line, it's actually a curve, but we don't know what curve it is. It could be like a sideways ellipse. That is possible. It could be hyperbola, rational function, right? Whatever it is. It could be anything. But I'm gonna look into it in depth. So we have a let's say we had a circle there, then we continue from that point to here, then we continue to there, and we continue that way, let's say. What is that graph? Well, that is the square root graph. That's what it looks like to me. Because if we move this to the origin, then it looks like a square root graph. And that too, y equals square root of x. No transformation. So this is just square root of x. And you can't just take a look at it and guess. I actually looked at like all these grid points and like saw that here, right? And then here, right? They're like really specific. So sometimes on tests it's gonna be really obvious because they're gonna make it neater and better like that. But yeah. Yeah, and so when you don't know, when there's like a curve, just move it to this origin and then try to relate it to a parent graph that you do know. And they're not going to give you anything weird like I don't know, like an ellipse that's diagonal. That would be really weird. So yeah, unless that's something that you've learned. So yeah. Now next, now we need to look at the like where it is. So we realize that at -2 is an open circle. So you have -2 as less than or x, so x is greater than -2, not greater than or equal to, since it's an open circle. And then the other side of the graph is at x equals 2. So, and then that's a closed circle. So we have less than or equal to 2. I hope you guys understand these inequality kind of like chains. You can just make sense of them. You can just look at them in parts. So you can look at this part, and then after that you can look at this part. And then you can kind of piece together how they both work. So now, yeah, let's continue on this part. On this part, we have that's a horizontal line, so we just have y equals whatever value that is. That's 1. The y value stays constant at 1. So we're just looking at y equals 1, where we have an open circle and then an arrow. So that means that we have, and that open circle's at x equals 3. So we have 3 is less than x, or x is greater than 3. That's probably a better way to write it. That's how we graph that. So basically, piecewise functions are just looking at parts of the graph and using the ones like known graphs to create a new graph. Things to look at and to keep part of and to keep notice of and be aware of are open circles, closed circles. Oh my god, what the heck? Open circles, closed circles, and arrows. That's what you need to keep. Arrows and both directions, right? And you also need to look at these open circles are less than and greater than. These are less than or equal to and greater than or equal to. These are just no ends, right? So yeah. That's it on parametric equations.